Hi guys, so today we're going to do some more fun with differential equations. This time we're looking at second order differential equations. And we're going to be looking at those linear forms where they're in the form a d2y dx squared plus b delta dy dx plus cy equals 0. Now, with these types of second order linear differential equations, we do have general solutions for them, but we also have a special equation that's related to it called the auxiliary equation. So whenever you get second order differential equations of this form, you can rewrite this in the form am squared plus bm plus c equals 0. And this is called your auxiliary equation. I think I'll write the full word so you guys can see a bit of spelling there. This is called your auxiliary equation. Now, with all second order linear differential equations of this form, you will always have these types of auxiliary equations. And you can tell that these equations are easily solvable by use of the quadratic formula. Now, when you're using the quadratic formula, there's several different solutions you can get. Sometimes using the quadratic formula, you can get repeated roots, you can get distinct roots, and you can also get imaginary roots. So for this type of order, second order differential equation, there's actually 3 different general solutions, and I'm going to show you all of them. So the first one is, what if we used the quadratic formula and we found out that b squared minus 4ac was greater than 0? Well, this simply implies that your roots are distinct. Your roots are distinct and real, and you would have 2 separate roots, such that you would have possibly your root values of m1 and m2. Now, in a case like this, where you have 2 real distinct roots, you would have a general solution of the form y is equal to a e to the m1x, where m is your root, plus b e to the m2x, where m2 is your second root for that type of solution. Now, what if we have our roots not being distinct? Well, the second condition that we can encounter is where we have b squared minus 4ac being equal to 0. If this happens, that simply implies to us that our roots are equal. So you get one value for m. So getting one value for m means that we will have 2 roots, m1 and m2, but because they are the same, we will have a case of m1 and m1. A general solution to this type of situation simply means that we would have a form of y is equal to ax plus b e to the m1x, where m is your singular repeated root. Now let's look at the third and final condition that can happen, or case rather. So what if we find that b squared minus 4ac happens to be less than 0? Well, that definitely would imply that your roots are imaginary. You'd be finding the square root of a negative number in some form or fashion. Now, if this is the case, then that means that your roots would take the form of, you can say, P plus or minus IQ, where P and Q are simply whatever result you get from using your quadratic formula, and your general solution based on imaginary roots would simply be equal to y is equal to e to the p x, where p is your real part of your root, multiplied by a cos qx, where q is the coefficient of that I, plus b sine qx. And there you have it. So recapping with you guys, first of all, a second order linear differential equation takes the form as follows: a d2y dx squared plus b dy dx plus cy equals 0. And there's a special auxiliary equation that we can use to change the form into a solvable one, where a, b, and c represent the coefficients of each of our derivatives, and our c represents the coefficient of y. That's called the auxiliary equation, and we use it to create, we recreate that equation so that we can use the quadratic formula to solve. Now, when you're using the quadratic formula to solve, you can get real roots that are either distinct or the same. And if those two cases take place, you would have your general solution looking in the following forms. And of course, if you had imaginary roots, you would have a little bit of a longer general solution, where P is your real part of your imaginary root, and Q is your coefficient of I. And be sure, guys, to look at my upcoming videos. I will be doing some examples of all these three conditions. Now, I also want to highlight something about the second order types of differential equations, and that's that usually, I'll write it on screen here. So you have we have second order differential equations, but they can be split into two categories, and one category is called the, we are not doing biology, homogeneous, and the non-homogeneous. All right, so for the homogeneous type of differential equations, that's where we have your equation being equal to 0. So you would have your standard equation, but it's equal to 0 on your right hand side. And your non-homogeneous equations, you will have your left hand side being some form or fashion of a second order. And on your right hand side, it's not going to be equal to 0. Whatever is written on your right hand side is some function of x. And there are special features that need to be applied when solving these equations. The general solutions includes something called a particular integral, as well as a complementary function. So we'll be looking into those types as well throughout these videos. So please be sure to hit that notification bell, because I'll be doing a lot. I'm hoping to finish differential equations within the course of this week. And it's because my students are doing a study on module 3, and they wanted that extra help. So guys out there, if any of you guys are interested in getting that extra help for free, Feel free to leave a comment down below and you can tell me what topic you're interested in seeing, and I can try my best to do a tutorial session for you. I want you guys to know something. Yesterday, I had um, a student message me and say that they were speaking to their friend, and their friend was telling them, I think I'll draw a diagram while I'm speaking. But their friend was telling them that they were doing some revision and they reached quite far, and that student didn't reach as far as they did, and they got a bit sad, and they were thinking to themselves, it's time to, of course, I need to ups my game, but they started to get very, very not so happy and not so confident. And I told them it's not good to compare yourselves with others. Don't compare. All right, we all move at a different pace. Um, you need to be yourself. You need to have a focus. You need to definitely set uh, some sort of target, and you need to head towards it, but your pace may not be as fast as others. What's important is that whatever pace you're moving at, you have to make sure that it's a pace that will get you from your point A towards your point B. Okay, guys, so maybe I'll leave some exam tips in a upcoming video. Who knows? Things that you wish you knew before exams. I might make a video on that. All right, guys, so be sure to change your frown into a smile, and know that it doesn't matter what somebody else is doing. Just be true to yourself. Make sure that once you love what you do, it's never work. And just try to enjoy your journey every day. And all the best. Take care and goodbye.